In this question, we're asked to balance the following redox reaction in acidic solution. And we have iron 2 plus IO3 minus yields Fe3 plus I2. And I just want to remind you one more time, and as it's in several playlists, Leo the Lion says grr. So this means losing electrons is oxidation, gaining electrons is reduction. So let's look at iron first. Over here it's plus 2, over here it's plus 3. So if the charge increases, it's lost an electron. So losing electrons is going to be your oxidation. On the next case, we have iodine, which goes from something to an oxidation state of 0 because it's elemental. Well, we need to figure out what the oxidation state over here is, and this should be reduction, right? Because one thing should be oxidized and one thing should be reduced, but let's figure out what the oxidation state is. To do that, we do iodine, the oxidation state on iodine, plus 3 times the oxidation state on oxygen, which is negative 2, equals the overall charge on the species, which in this case is minus 1. So it's iodine plus 3 oxygens, each with a minus 2 charge, equals minus 1. Iodine minus 6 equals minus 1. Add 6 to both sides, and iodine equals plus 5. So it goes from plus 5 to 0. So it gained 5 electrons. Gaining is reduction. So this is the reduction half reaction. So let's start with the oxidation half reaction. We have, in the oxidation half reaction, Fe2 plus aqueous yields Fe3 plus aqueous plus an electron. So that's our oxidation half reaction. And then now let's look at our reduction half reaction. We have IO3 minus aqueous yields I2 solid. And in this case, we need to figure out how many electrons we've transferred. Well, if it went from plus 5 to 0, then we have transferred 5 electrons. So we need to add 5 electrons to this. Now, when we notice this, we notice that there's 1 iodine here and 2 iodines here. So we do need to make 2 of these, and then that'll make 10 electrons. We also need to consider one other thing. There are oxygens on this side, but no oxygens on this side. But because this is happening in an aqueous solution, we need to add 6 oxygens in the form of water. So we have 2 times 3, which is 6 oxygens. So we need to add 6 H2O liquid to this side. And then finally, to balance out the hydrogens, because it's an aqueous acidic solution, and even if it's in basic, you do it acidic first, we need to add these hydrogens as H+. Well, there's 12 H's, so we need to add 12 H+, and that's aqueous. And I didn't leave myself space for that, but hopefully you can see that jammed in there. So basically we have 2 IO3 minus plus 12H plus aqueous plus 10 electrons yields I2 solid plus 6 H2O liquid for this half reaction. Now we want to add these reactions together in a way that the number of electrons cancels out. Well, if we have 10 electrons in this reaction, we need 10 electrons in this reaction. So we multiply everything by 10. We just do the reaction 10 times. Now the electrons will cancel out. Recall that to add reactions together, we simply write everything on the reactant side from both reactions, everything on the product side from both reactions on the product side, and then cancel anything out that's on both sides. So in this case, we have 10 Fe2 plus aqueous plus 2 IO3 minus aqueous plus 12 H plus aqueous plus 10 electrons yields 10 Fe3 plus aqueous plus 10 electrons plus I2 solid plus 6 H2O liquid. And hopefully you can see that. So I basically just wrote everything out. Now I notice there's 10 electrons on both sides, and in this case that's the only thing that cancels, so we cancel those out, and then we rewrite it 10 Fe2 plus aqueous plus 2iO3 minus aqueous plus 12H plus aqueous yields 10 Fe3 plus aqueous plus I2 solid plus 6H2O liquid. And that's basically that. If you check to make sure everything's balanced, you have 10 ions on this side, 10 ions on this side, 2 iodines on this side, 2 iodines on this side, 12 hydrogens here, 12 hydrogens here, 6 oxygens here, and 6 oxygens here. Everything is balanced and canceled out. So this is how you would do it in aqueous acidic solution. Let's look at another example here where we have it in basic solution. It says, balance the following redox reaction in basic solution. And we're basically going to do the same thing, except at the very end, we're going to basically cancel out things for OH minus. And let me show you how to do that. So the first thing we have is we have zinc going from 2 plus to 0. So here we have it at 2 plus, or plus 2 to be consistent with before, and here it is at 0. So when zinc goes from 2 plus to 0, that is going to be reduction. So it has lost electrons. What am I saying here? This is, I'm looking at the other example here. Zinc has actually gained electrons, so it's reduction. It is reduction, but it's because it's a gaining of electrons. So gaining electrons is reduction. Sorry, I got confused there for a second. Hydrogen, in this case, is 0, in this case is plus 1. So hydrogen has lost an electron, so it has been oxidized. So let's look at the oxidation reaction first. Here we have H2 gas yields H2O liquid. We have 2 hydrogens and 2 hydrogens. It went from 0 to plus 1, so therefore we needed to gain 2 electrons because there's 2 hydrogens, each gaining an electron. Well, we have the same issue as before. The issue is we have oxygen on this side and no oxygen on this side. So how do we get oxygen over here? Well, what we do is we add a water. And now we have 2 hydrogens here and 2 hydrogens here for a total of 4 hydrogens, but we only have 2 hydrogens on this side. So what we need to do is we need to add 2H plus aqueous. Now you may be saying to yourself, how can you add H plus? This is in basic solution. Well, the very last thing we want to do is we want to neutralize the acid. And we want to do that by adding 2 OH minus to each side. So if we take this and we get hydrogen gas plus H2O liquid plus 2 OH minus aqueous yields H2O liquid plus 2 electrons plus, now we're going to take OH minus and add it to H plus. Those are going to neutralize each other, and we're going to end up with 2 H2O liquid, like so. Now you'll notice you have 3 waters on this side and 1 water on this side. Said another way, this cancels out, and the half reaction finally becomes H2 gas plus 2 OH minus aqueous yields 2 electrons plus 2 H2O liquid. So you do the exact same thing as you did above for the by adding acid to both sides, and then you neutralize that acid by adding the same number of OH minuses to both sides, so you get OH minus in this case on your reacted side, and your H plus interacts with OH minus to form 2 waters. So this is your half reaction for your reaction here. Now let's look at the other example. We have zinc 2 plus, and it's going to form with 2 electrons zinc, solid. And this is your reduction reaction here. So we have zinc, which is aqueous, and we're going to add 2 electrons to it, and it's going to become solid zinc. In this case, we don't really have to do anything, because if you notice, there's 2 electrons in this reaction, and 2 electrons in this reaction as well. So we're good to go. We can now add these together. Remember, to add the reactions together, you take everything on the reactant side, and you form everything on the product side. So in this case, let me pull this up, we end up with H2 gas plus 2OH minus aqueous plus zinc 2 plus aqueous plus 2 electrons yields 2 electrons plus 2H2O liquid plus zinc solid, like so. We have 2 electrons on both sides. Of course, we did that on purpose. You don't necessarily have to write this all out. We can cancel those out. Nothing else cancels out here. And what you end up with is H2 gas plus 2OH minus aqueous plus zinc 2 plus aqueous yields 2H2O liquid plus zinc solid. And this is for a basic reaction, so we do have OH minus here. Let's check. We have 4 hydrogens on this side and 2 4 hydrogens over here. 2 oxygens, 1 zinc, and 1 zinc. So this is the balanced redox equation for the basic solution. So these are quite a lot of work, but you basically do them both as if they're an acid, and then you fix the one that's in base by adding the appropriate number of OH minuses to both sides, as was shown here.